All right, awesome. Thanks, Jerry. Well, let's go ahead and get started. Welcome to co-channel interference and its impact on Wi-Fi performance. In this webinar, we're going to talk about co-channel interference and what it can do to impact the performance of your wireless network, and namely what you can do to design a network to minimize co-channel interference as much as possible. Now, co-channel interference isn't something that you can get rid of entirely because it's just an inherent part of Wi-Fi and how it works, but it is something that you can design a network to avoid as much as possible, and that's a very good thing. So let's do a couple quick introductions so that you know who we are and I guess know who we are. My name is Joel. I am the technical trainer here at Ekahau. I am joined with Jerry Ola, who is our product manager here, and also not on this slide because we don't have a cartoon for him yet. I think we really need to get one though. Is also Clayton Matthews. Clayton is our sales engineer for North America. And I don't know, Clayton, I think your plan here is just to provide color commentary in the background. Is that what you're going to do?
That's what I do.
All right.
Answer questions. So
perfect. A couple quick housekeeping items too, just so that you know what the agenda is. We'll talk about what co-channel interference is. We'll talk about what it can do to your network, and then we'll spend a bunch of time in live demo talking about how to optimize a wireless network to minimize co-channel interference as much as possible. And then at the end, we'll follow up with some Q&A. A couple housekeeping items for you to keep in mind as we're going through this webinar is that we've noticed that people love to use the chat, and we love to see everybody engaging, not just with us, but with other attendees in the chat. So if you want to do that, go ahead and open up the chat. And if you send your chats to all panelists and all attendees, it's that little blue drop-down box there right above the box you type things in. If you change that to all panelists and all attendees, that will allow everyone to hear you, and that way you can have conversations with each other, not just us. Also, if you have questions, Jim says that his is gray. So Jim, you're probably on Windows. Maybe it's a Windows or Mac thing. I don't know. Also, if you have a question, feel free to use the Q&A tool. It's a great place to type in formal questions that will kind of ensure that we get to them. If things get busy in the chat, that'll often fly by and we won't see everything that's there. But if you put them in the Q&A, that's a really great way for us to to be able to answer all of those questions. Also, you can upvote interesting questions in the Q&A tool. Jerry, do you remember, did we enable that for this one? All right. Jerry says,
I checked the box.
Sweet. All right. You're a really good box checker, Jerry. Good job. So yeah, we've checked the box that you can upvote other people's questions. So if you see an interesting question that you also have, then just go ahead and use the upvote tool and do that. So I don't know, Jerry and Clayton, did I miss anything? Or are we? I think we covered.
I think we're good. The recording is going. So yeah, if you will get a link to the recording probably within like 24 hours or so when that's uploaded. But yeah, I think that's everything.
Yeah, awesome. Cool. Well, let's go ahead and jump right in. So I think the first thing that we need to talk about is what is co-channel interference. This is a subject that's very near and dear to my heart because I feel like it's very central to Wi-Fi. And it seems like whenever I teach a little class or do a little workshop or something like that on Wi-Fi in general, if I skip this, if we don't talk about co-channel interference, that leads to a whole bunch of problems down the road when you're trying to learn all these technologies and things as you dig into deeper discussions in classes and workshops. And so at this point, I almost always start out with this. This is always where I start. It's kind of like when you're learning math, when you're learning algebra, you have to start with kind of the base level stuff and then work your way up. I feel like co-channel interference is one of those core foundational things in Wi-Fi that you just have to understand. So here's the big thing to keep in mind when you're working with Wi-Fi in any capacity, in any way, is that Wi-Fi is half duplex, which means that on any given channel at any given time, only one device can talk. One thing can transmit on a channel at a time. It's a lot like walkie-talkies. When you're holding down the talk button and talking into a walkie-talkie, nobody else on that channel can transmit. Only one thing can transmit on a channel at a time. And so what a conversation typically looks like, let's say that we have an access point that needs to send some data to, let's say, to this iPad right here. The access point's going to wait until there's nothing talking on the channel. It's going to wait for an opportunity to talk, and then it's going to transmit its data to that access point, and then the access point's going to reply with an ACK or an acknowledgement. So it's this constant process. It's a lot like TCP/IP, where we send data, we receive an acknowledgement, we send data, we receive an acknowledgement, and we do that over and over and over again. That works great when you have one access point and one client device. But what about when you have 10 clients and one access point, or 50 clients and one access point? Jim, I'm sure you could probably tell us, what your maximum client counts on your APs look like. I'll bet you've got APs that are just loaded with client devices, and I'll bet you could probably tell us that you don't really run into the limits of what the AP can handle. He says 180 clients on one radio. And Jim, you could correct me whether I'm right or wrong on this, but my guess is that since you're using good enterprise grade access points, my guess is that you don't really run into access point capacity limits. You probably run into capacity limits on the channel. Maybe you could tell me in the chat whether I'm right or wrong on that. And I'm taking a bit of a risk there asking that. Oh, he says I'm right. Whew, okay, we're good. So you don't really run into the limits of most enterprise grade access points. You run into a limit of what the channel can handle, because there's only so much time available on a channel. You start stacking up a bunch of clients on that single channel, and pretty soon you've got all these devices taking turns talking, and you simply run out of time. You run out of opportunities for devices to transmit. Another thing that affects this as well are data rates, what data rates you're using. When you transmit at a nice fast data rate, you get on the channel and get off the channel really, really quickly. You get on the channel, say what you need to say, and then you get off the channel. If you're transmitting at a really low data rate, that causes that device and that conversation really to consume a lot of time on the channel. So for example, if we've got, I'm just going to use 802.11g data rates for simplicity here, but let's say that we've got, we'll say this is 802.11a data rates. So let's say that we've got an iPad here, and it's talking back and forth. We're able to maintain about 54 megabits per second in that conversation. AP is using around 54 megabits per second to talk. Clients replying back with around 54 megabits per second, give or take a little bit, but we'll just nail it down at 54 megabits per second. That's going to be a nice, fast, efficient conversation. We're going to get on the channel and get off the channel really, really quickly. If we've got a device that's really far away from the access point, maybe it's had to fall back all the way down to 6 megabits per second. If it's having to transmit very slowly, maybe whenever it transmits back to the access point doesn't reply with an ACK. The access point never says, "Yep, I got your data." And so then that iPad starts to go, "Ooh, well, I'm gonna go back down to a lower data rate and try again. And I'm gonna go down to a lower data rate and try again." It's gonna keep doing that until it arrives at rock bottom at 6 megabits per second. Whenever that iPad comes on the channel to talk, it's gonna consume a ton of airtime, because it has had to ratchet down to a very slow data rate to make sure that the access point can understand it. And if it's using a slow data rate to talk back to the access point, chances are the AP is using a fairly low data rate as well. Maybe the access point is also having to transmit back at 6 megabits per second or 9 megabits per second or something like that. And so speed is a very, very important factor here. The slower devices talk, the more time they consume on the channel. The third thing that you can see come out of a situation like this are lots of retries. So if we've got a client device that's really far away from the access point, or maybe there's some noise, some non-Wi-Fi interference, all kinds of different things can do this. Adjacent channel interference, maybe maybe if this was happening in 2.4 gigahertz and there was some rando shows up on channel 5 and interferes with your AP on channel 6, that can cause this as well. We can actually run into retries. So if the access point transmits to the iPad and the iPad doesn't understand it, it'll just do nothing. And then the access point will start to go, okay, well, I never heard an acknowledgement from the iPad, so it must not have received the data frame. And so transmit that data. And it will transmit that data over and over and over again until finally that data makes it through and the iPad can go, "Yep, check, I received the data," and it can reply with an acknowledgement. That also consumes time on the channel. That generates co-channel interference. Jerry, do you have any comments on any of that so far? Is any, I don't know if you've been watching the chat or questions or anything like that, but what do you think so far?
You totally lost me. I don't know. I don't even know what we're talking about anymore.
Well, I expected that.
No, I mean, I think this is the obviously fundamental type stuff. I'm sure a good amount of our audience is already well familiar with this, but I think, one of the things that, thinking back to kind of my journey learning about Wi-Fi, and, obviously still very much am, but, through this particular topic, the whole, just because you can't see it doesn't mean it's, infinite, right? There's a finite amount of spectrum that we have available, and, we have a finite amount of channels that we can reuse in the environment. So it all plays into this topic.
Yeah, absolutely. And I think we've actually got, I don't know, do you want to talk about channels now or do you want to hold off a little bit on that?
We can hold off on it for now. What
Okay,
other?
cool. We'll loop back around to that in a little bit. So I think one thing I want to stop and talk about really quickly is just the effects of co-channel interference and what you see with your measurement tools when you start to see co-channel interference. Now, an obvious one is going to happen at layer 8, right? Users are going to become frustrated. I typically find that once you see that a channel is utilized more than about 70% of the time, that's typically where I start to see things break down from a user experience standpoint. That's where they have difficulty sending messages. That's where they have difficulty loading web pages. That's where things really just start to break down because your client device, your access point simply cannot achieve an opportunity on the channel to talk. So the two indicators that I always look at to get an idea of what my health is kind of from a co-channel interference standpoint. The first one that I look at is I look at utilization. Now, utilization, I see this as a layer 1 measurement. This is something that you're going to look at with a spectrum analyzer because this is going to look at the raw radio frequency activity to see what is happening in the air on a specific channel. You might go look at channel 64 and go, how often do we see RF on that channel on channel 64? And if we see 45%, well, okay, that's a busy channel, but 45% should be okay as long as we're not doing like voice over IP or something like that. I'm not too worried at 45%. But once we hit anything 70% or beyond, if you even see above 70%, you probably usually won't. That's where things really, really start to break down. And so that's one of the things I always do is I look at things with a spectrum analyzer to kind of see, what is going on. Jerry, that number, when I say 70% being kind of the breakdown point, I don't know, what's your experience around that? Do you feel like that's kind of the saturation of a channel that you see where things start to break down?
So this is an interesting topic, and I'm curious if anybody in the audience here has any maybe real world experience with these types of things. I do agree from the breakdown standpoint of usually you can push things even to maybe the point of about 80%, and data is still going to work. Utilization. What we're talking about there is how busy the medium is, and the more time the medium is occupied, that channel is being occupied, the more delay, right? The more contention that has to happen. So obviously certain services are going to start to break down sooner than others. Yeah, like Joel's putting in voice. So voice is going to start to break down if 50% of the time that medium is busy. That means 50% of the time when your Wi-Fi device, your phone, your voice client needs to be able to transmit it has to back off and wait. Data obviously isn't going to be as susceptible to that, and that's why we say it can withstand higher percentage thresholds. Before, from a user experience standpoint, they're going to start to complain and be like, the Wi-Fi is slow, the Wi-Fi is not working. Wi-Fi latency sensitive applications like voice are going to break down much quicker. So I see a few percentages there in chat about 50% for voice, 60% for data. And data is obviously all kind of relative, right? What is the data that you're moving? If you're doing something like, buffering a video, it might take a little bit longer to buffer, but even with 80% utilization, you can still watch your video. It might just take a little bit longer. But if you're doing something else that you need, more of a back and forth kind of a communication of sending and receiving data, and your channel's occupied 80% of the time, it's not going to be a great user experience. That said, the other side of this coin, talking about co-channel interference and kind of the effects of it, one thing that I've found, and this is the main thing I'm curious from our audience standpoint, is if you have high amounts of co-channel interference, you actually will not see a channel necessarily being occupied at 100% utilization. Co-channel interference doesn't necessarily mean 100% channel utilization. Actually, if you are utilizing 100% of the channel, that's more of an indication, and it's Wi-Fi energy. That's more of an indication that the Wi-Fi, that there's not co-channel interference, and that the Wi-Fi medium is just very busy, and that it's working efficiently, and that things aren't necessarily having to continuously back off, because backing off means that something is not able to transmit, right? So there's a lot more contention on the medium. So yes, if you have high co-channel interference in a very busy environment, you probably won't see a channel ever be occupied more than 80%, maybe even more than 70%.
Yeah, absolutely. And Bruce says that co-channel interference creates the potential for high utilization. I agree. I absolutely agree with that. So now, kind of the other way that we can measure this is to look at airtime. And so when we look at airtime, we're actually moving from layer one. We're moving from using like a spectrum analyzer and just looking at raw RF. This is where we start to move up into the, we move up a layer in the protocol stack. Now we're actually looking at how much time devices will reserve on the air when they go to talk. Whenever a device, this is simplifying a little bit, but for the sake of this discussion, I think it's fine. This is where we'll actually look at how much time devices are reserving on the air. When devices go to transmit, they'll say, hey, everybody on the air, shut up for this much time. I'm going to talk, and this is how much time I'm going to consume. It's called a nav timer. So that's moving up a layer and looking at another layer, and you can do this with a packet analyzer like Wireshark, like IPA. Lots of tools out there will show you how much time a packet is consuming on the air. And when you see heightened co-channel interference, you're absolutely going to see increased airtime usage because you're seeing more devices consuming more airtime, reserving more time on the air to talk. And thus, it turns into a competition where devices are continuously competing for opportunities to talk. So there's a lot of different things that will contribute to co-channel interference. My kind of opinion on co-channel interference is that it's an unavoidable part of Wi-Fi. Co-channel interference. Go ahead, Jerry. What were you going to say?
If you can go back to that previous slide real quick. One thing I did just want to add into that is, this is kind of a, coming from the product side, one of the things that we've recently rolled out is echo capture. So you mentioned things like Wireshark, IPA, those kind of things. So one thing I would say is, on the layer one utilization, with the Sidekick and the spectrum analyzer, we can certainly capture that spectrum information and the channel utilization from a layer one perspective. However, with Echo Pro and a Sidekick, you're not going to necessarily be able to see this layer two airtime utilization. That's going to require some deeper analysis to be able to reveal that side of it. So to like the point that I was trying to make before on the layer one is if you're relying purely on layer one information and just looking at Wi-Fi measurement of signal, and we're not connecting all the dots of that layer two aspect of how busy the channel is from a layer two standpoint, then that's where we need to have some additional tools, right? We need to dig in a little bit deeper, do a packet capture, analyze those information elements that Joel's talking about. And there's ways you can spit out the graphs even in Wireshark, but IPA does a really good job of visualizing this airtime aspect. And there's not a lot of tools out there that I feel like do a good job of that. But yes, if you first look at it from a utilization standpoint, as I mentioned before, you might only see 70-80% utilization on the channel and think, oh, I've got still 20-30% of the channel available. Why is everybody complaining that the Wi-Fi is slow or not working? But then we look at it from an airtime utilization standpoint and that layer two aspect, and now we can see the medium is just solid busy essentially 100% of the time.
Yeah, absolutely. Good stuff there, Jerry. Thanks for that. So some things that will contribute to co-channel interference. One of the big ones that I see is low data rates. So whether this is because you have lower data rates enabled on your network, or whether this is because devices are falling back to lower data rates. Now, whenever a station transmits, that can include both an AP and a client. Whenever a Wi-Fi station transmits, it is going to basically pick a data rate, and that is often based on retries. Now, every chipset out there does it differently. They all have different ways that they decide what data rate they're going to use, but this is commonly done with retries. And so if a client device is transmitting back to an AP and it's just consistently having to retry, it's going to move down a data rate. And if it's still having to retry, then it'll move down a data rate again, and they'll continue to do that until they hit rock bottom, basically. Eventually, the chipset will just give up and disassociate from the network or try to find a new AP to associate to. So low data rates consume more time on the channel, thus they contribute to co-channel interference. Next are retries. If you have to repeat what you're trying to say, that's going to consume time, right? And so we want to limit retries as much as possible. We want to get data delivered on the first time. We want to get it delivered reliably, which is why I think, and Jerry and Clayton, maybe you can comment on this a little bit, But that's why I think we see a lot of people say, their coverage requirement is negative 67 dBm, or their coverage requirement is maybe negative 65 dBm. It's because they want to provide good enough signal strength that we can always just transmit the first time, 80, 90% of the time we could transmit and not have to do a retry. Does that sound about right to you, Jerry? Around neg 67, neg 65, something like that. Yeah.
Mm-hmm.
Next, and I think Jerry's going to talk about this one in depth in live demo, is either bad channel plans or no channel plans. I think we've all opened up a Wi-Fi scanner at some site and we see that there's absolutely no channel plan at all. Maybe all of the access points are stacked up on the same channel. When we do that, well, if we're limited by capacity on one channel, we're essentially wasting all of these access points because they're all having to compete for opportunities to talk because they're all on the exact same channel. So by implementing a good channel plan, we can get those spread out onto different channels and make sure that everybody has opportunities to talk. And then there's things like bad AP placement. If we line up APs up and down the hallways, well, the problem with that is now all of our APs can hear each other perfectly well. And so I think Jerry's going to talk more about things like bad AP placements, things once we get into live demo. Now, before we talk about before we jump into live demo, Jerry, do you want to talk about channels for a couple of minutes?
Yeah, I think we can. I'm sure everybody's seen charts like this before. I really like this one. This is from the WLAN Pros website. But yeah, this is the 2.4 side. I feel like we've always, this topic's been covered over and over again, so we won't spend too much time. But yes, we've got a lot of channels available in 2.4, but we actually have a very limited amount of spectrum. So what that equates to is we really only have 3 channels that we can use, and this chart does a good job of kind of visualizing that 1, 6, and 11. You can technically pull off potentially a 4-channel plan for outside of the U.S. and areas that allow you to use things like channel 13. But that's obviously, there's a lot of kind of caveats to that of other things that might be operating in between channels that can restrict you from doing that. So in most cases around the world, 1, 6, and 11 is the kind of widely accepted way of avoiding adjacent channel interference, which is a whole other topic. So since we're talking about co-channel interference, we're talking about specifically 2 BSSs or OBSSs, the overlapping cells that are occupying the same channel, the same frequency.
Yeah, and then up in the 5 gigahertz band, I don't know if you have any comments you want to make there, Jerry.
Yeah, so this is really just to illustrate there's a lot more variables, compared to the previous slide on the 2.4 side. The main thing that we have to contend with are the in-between channels, and obviously a lot of other non-Wi-Fi interference. But in relation specifically to co-channel interference, there's a lot more variables in the 5 gigahertz space. First and foremost, we have a lot more spectrum to work with, which means there's a lot more channels that are in actual proper separation between those channels. So as it starts out, 5 gigahertz is really great to alleviate a lot of these pain points that we deal with in 2.4 on co-channel interference. However, there's also a lot of other things like channel bonding that we can do where we start to lose some of the big benefits of 5 gigahertz and those proper channel separations. And when we start to bond channels together, we have less channels that we can reuse as we combine those channels together. And you can kind of see that breakdown there in the chart, where we start out with a nice group of 25 channels, and then we start to break down from there. We group them together and we basically kind of divide that in half, and then we combine that together again to make 80 megahertz wide channels, and again divide those number of channels in half, and then you can see you can go all the way up to 160 now in 5 gigahertz, which essentially gives us a 2-channel plan, so less than we have available in 2.4. But yeah, even at 80 megahertz, let's say we can't use the Uni 2C part of the band there, and all we can use is Uni 1, the Uni 2A, and the Uni 3. Now we're back down to a 3-channel reuse plan, essentially, in comparison to the 2.4 side. So that's why we typically avoid using things like 80 megahertz wide channels in an enterprise environment where you have a lot of access points. We can a lot of times pull off things like a 40, or even if it's a very dense environment, stadiums, auditoriums, things like that, where we have a lot of APs in a given area. We may have to, go down and commonly go down to 20 megahertz wide channel plans. And then below that, you can see there's all sorts of other considerations depending on where you are in the world. So in the US here, we go by the FCC guidelines or the I don't know, what is it, the restrictions that they have in place.
I was
And
going to
then
say, I don't know if those are
not
guidelines.
guidelines. Yeah, I knew I had said that incorrectly.
Sorry, I couldn't
very,
help it.
very stern guidelines. They will come knocking on your door if you don't abide by those guidelines. But yes, they are more than guidelines. They are legal type things that you have to abide by. So yes, you can see there's different things around the world that do vary. So there's just a lot of considerations there, especially if you're working for a global organization and you've got to do channel plans for different parts of the business in different parts of the world. You can't just copy and paste these things, right? We have to take extra consideration there. Obviously, we have things like auto RF things that are supposed to help with some of this kind of stuff and automate some of this complexity. But we still have to know what the stuff is. We still have to design the network for those auto RF capabilities to work. And auto RF capabilities don't work in all environments, right? And it still needs a lot of massaging and fine tuning to actually make this stuff work optimally. So it's good to know these kinds of channel allocations.
Yeah, absolutely. Cool. So one last thing before we jump into live demo is this is actually a little bit of a Venn diagram. Can I draw circles? Oh, I totally can. This is a bit of a, I'm not going to leave the circles here, but there's a little bit of a Venn diagram here. Jerry, you can maybe you can kind of give your opinion on this, but I feel like there's kind of three ways to visualize co-channel interference in Ekahau, three primary ways. The first of those being airtime utilization. So airtime utilization is a simulation. So this is something that we do on the planning side in Ekahau Pro, and this is going to basically calculate how much time on each channel is going to be consumed by access points and clients, and Jerry's going to demo this stuff. Next is channel interference. This is probably the one that we look at the most. This is probably the most common one that we look at. This is both a simulated and a measured thing. You can look at this in a simulation of a network, and you can look at this from the results of a site survey. This is going to show us the amount of access points that were detected on a channel above a specific threshold. So for example, this green spot right here, there's only one AP sharing, there's only one AP on that channel above negative 85 dBm in this example. And anywhere that's yellow, well, there's two or more APs sharing that channel above negative 85 dBm. And then gray is where we're seeing more than three or more access points sharing the same channel there. So this is the one that I look at the most. It's a very easy way to look and see what kind of an access points area of influence is around it. Finally, the last one is spectrum utilization. This one comes from the spectrum analyzer on the Sidekick. This is a measured thing, and this is the percentage of time that radio frequency activity was detected in the spectrum. So down here, that's probably 5% channel utilization right here. This red stuff in the middle, that's probably 70% utilization or more. And so that's just kind of the three different ways that you can look at how busy channels are in Ekahau, whether it's on a virtual network design or if it's on an actual survey. And so I think with that, I think we're going to go ahead and jump into a demonstration with our very favorite Jerry Ola. So Jerry, you want to go ahead and take over?
Whose favorite am I?
Everybody's.
Oh, everyone's favorite. I thought it was just yours.
I thought so. I don't know.
Oh.
Put it in the chat. If Jerry,
you're my favorite.
What's that, Clayton?
I said you're my favorite too, Jerry.
Oh, wow.
But see, one person out of 406 people has now confirmed it. So I don't know. Maybe the chat will confirm whether you're the favorite or not. So yeah, Jerry, take it away.
All right. So I put together this amazing project that I call CCI Trainwreck. And we're going to go ahead and actually I think basically I've created a huge mess here. And the thought that I had behind it was we're going to start with this huge mess and we're going to try and make an awesome Wi-Fi design out of this. So I took all the kind of things that I have commonly found in the real world of kind of mistakes, I would say, that are made that result in this kind of really negative RF environment when it comes to co-channel interference. And what are the reasonings that we have all this co-channel interference? And I didn't try to just do really horrendous things of put all the APs on the same channel, which is really obvious. And, most people thankfully don't do that. but more common mistakes that we do see. And let's take this project file, and actually Joel and Clayton and I shared this. I uploaded this to Echo Cloud and shared this with you guys, so if you want to pull it up on your end to dig around while I'm kind of walking through some things on my side, feel free to do so. But yeah, let's starting out with what we've got on the screen right now, kind of looking to the audience here. Does anything jump out at you that could be a problem here? I'm looking at signal strength right now, and everything's green, right? Everything's good. We shouldn't have any users complaining. We've got good Wi-Fi coverage everywhere. Right now, I'm looking at both 2.4 and 5 gigahertz. But let's go ahead and switch over to like 5 gigahertz. And yeah, even 5 gigahertz looks great. So, I mean, we've got a nice solid network here as far as, the right number of access points for coverage. What do you guys think? What are you seeing?
I see lots of stuff in the chat. I don't know if I think you're working on a single screen today, but lots of things in the chat. First one that popped up. Well, Jim says it's all green, so that means it's good, right?
That's right.
Yeah. Joey notices that there are 80 megahertz channels in use there, so we're using tons and tons of spectrum with those. Yeah, go ahead.
So that's a great starting point. So you're hitting on some of the things already. So this is the way that I would approach this. So yeah, signal strength is great. We've got signal strength, so we can move on to other things, right? So there's more to a network than just signal strength, right? So I like to think of this as my Wi-Fi onion ball here. You've heard the term kind of peeling through the layers of the onion. And if we want to take a look at the very outer layer, we're going to look at network health, and we can see very quickly we've got some problems here, right? So on the network health view, it gives us a nice quick overview of just pass-fail indicators. I can even look at the visualization statistics here of what is the areas of our network that are meeting the requirements, and what are the areas that are percentage breakdown, what areas are failing. And almost 75% of this network is failing, yet on our signal strength everything was green. Now if I want to get a little bit more detail, I could hover my mouse over different areas and it'll tell me the reason why those areas are failing. Or to even just kind of peel through that first layer, let's get rid of all the areas that are working, that are green and passing, and let's just focus in on the areas that are failing. So I'm going to look at network issues, and now it's going to start to give me more detail about what are the issues that we're seeing with this design, and what's going to cause our users kind of some problems here. And sure enough, we can see this huge kind of purplish blob looking thing on my screen of channel interference is what this color is indicating. And if I hover my mouse over the one area here in the middle, we can see, sure enough, the limit that I have it set to right now is saying we can't have any more than 2 APs audible to meet that voice grade network is what this is set up to right now for the requirements. It says we can only have up to 2 APs audible on a given channel. So we're even given a little leeway there, saying we will allow a minimal amount of co-channel interference. But yes, here we can see we've got 4 APs audible right where I have my mouse right now, and that's on both 2.4 and 5. So this isn't just a 2.4 issue. So yeah, let's maybe start with the 5 gigahertz side, because somebody did mention the 80 megahertz piece of it, and that might be a simple, can we fix all of our issues by just, lowering our channel widths, give us some more channels to work with. Let's flip now through one more layer of our onion, and I'm going to drill down into channel interference. That's that one visualization Joel was just talking about. So this is the one that I usually would go to next, because that's what it's telling me the problem is. And since this is just simulation, we don't have the spectrum utilization view to leverage in this particular project, unless I go on site here and do some actual real world measurements. But for the purpose of this demo, we'll just rely on the simulation piece of this. So yeah, here we can see even now more detail. If I hover over some of these areas, we can see which APs are on which channels at which dB values. So we're getting more and more detailed information as we dig through these layers to exactly what kind of the root of the problem is. So yeah, channel overlap all over the place. Also, I will show this here. If you go to the visualization options, you can actually see there is some options here of how we want to visualize that co-channel interference. So we can look at, specifically just co-channel interference or co and adjacent channel. these are the defaults here. You can also say things like, if we want to look at channel interference based on the worst channel or the predicted associated channel, which is based on RSSI and which clients we would predict are going to associate to which APs. And then this is also another slider here to set your threshold of what you define as co-channel interference. And this could be based on your AP's maybe receive sensitivity. You could set it to that. So if your AP, receive sensitivity is set to or is only capable of decoding frames down to like -80, for example, adjusting that slider is going to have an impact on the visualization. Or maybe you're very sensitive APs and they can decode things all the way down to -90. We may want to adjust things that way. Right now, it's by default it's set to -85 is what we're going to consider co-channel interference. That's what the APs can hear, and that's going to trip up these APs to back off and cause that contention. All right, so yes, now we know pretty detailed here what's going on. I'll take that first suggestion around the reducing the channel width of the AP. So I'm going to use the auto planner here, and we're just going to drop down the channel width. I'm going to keep everything else the same right now, and we're going to just see how much of this co-channel interference can we eliminate by just dropping our channel width down to 40. And notice what happens going from 80, we had since I'm not able to use Uni 2 extended for the purpose of this demo, we took those channels out. I can only use Uni 1, Uni 2, Uni 3. So now if we drop from 40, we're going from 3 channels. Now we're essentially doubling the amount of channels, right? So now we've increased our channels to 6. Still not a lot, so let's see if we drop that down to 40. Can we pull off a good design here? And we'll look at just 5 gigahertz because obviously we're not doing anything with 2.4. So I'll switch this over to 5, and we can see, did we make any significant impacts there? So pretty big positive influence or improvement there by just reducing the channel width. So we doubled the amount of channels. We could eliminate a good amount of that co-channel interference. We still do have, even in these areas, there's at least 2 APs that are all going to be audible there. So we could certainly clean that up quite a bit more if we were to drop this down to 20. So still keeping the same channels, same unibands, but just dropping it all the way down to 20. So there we go. Now it looks like for this, if we can't use those Uni 2 extended channels with the current AP configurations, as far as transmit power, location, that kind of thing, we could come up with a much better channel plan, at least on 5 gigahertz. If we flip back over to 2.4, we're going to see that there's still a lot of co-channel interference on that side of it. So let's take a look at one more visualization here. Joel mentioned that airtime utilization. So let's see, what are the impacts of this co-channel interference? Is this devastating to our network? Is this going to be a big kind of train wreck, or is this just going to cause some users to have some problems in some areas of the network? And actually, I'm going to reverse that channel because I actually did want to show you guys this first before we kind of cleaned up the channel. So I'm going to switch our channels back to 80 and just see what that did to our airtime utilization. So we're looking at the airtime utilization view here now. And yeah, notice we're looking at 5 gigahertz and with 80 megahertz. Often people think, use the widest channel possible, get the highest data rates, get people on and off the medium super fast because they're talking so quickly. But when everybody has to contend for that airtime, it actually has the opposite effect. And we can visualize that in the tool here and figure out what is the right configuration for this network. And here under the visualization statistics, you can see that, actually, even on the 5 gigahertz band, 11% of our network here is showing that we're going to have 70% or greater utilization. And then, a lot of other, 13% here at 50 to 60% as well. So let's optimize that channel plan. Again, we'll drop that back down to 20. We know that was the right solution. And then what's some other things that we can do to further improve this network? Thinking of the simplest things first, right? Without taking drastic measures. There's a lot of drastic things that we can do, and we'll get to those in a bit. So I'm taking a look at chat. Anything you guys have seen, Joel or Clayton, in chat on some good suggestions?
Well, Jim, did you try 40s? I was looking at something else. Did we run through 40s, or did you just go straight to 20s?
No, I did. I did in the original when I started. We did switch from 80, 40, and 20, and I agree with Jim that
Yeah.
I would kind of drop down. So yeah, I don't usually go right from 80 to 20 if you can pull off 40. So the rule of thumb, actually, I think this comes from Keith Parsons. If you guys know him, he's made the rule of thumb is use the widest channel you can while avoiding co-channel interference.
And it's nice because in Ekahau, you can just kind of, it's really quick to test it and look and see like, okay, well, if you use 40s, what's it look like?
Yep.
So one that Nick suggests is to disable data rates, prune off slower data rates. And I think we actually had a question about this earlier. Is it a good idea to prune off slower data rates? If you're working in 2.4, do you get rid of 1, 2, 5.5, and 11 megabits per second? What do you do from a data rate standpoint?
Yeah, I like it. So yeah, and this was actually, if we look at the questions, I believe there was a really popular question in the questions as well around data rates, right?
Yeah, Brad asks, what are the benefits of disabling lower data rates? Does it make sense to do this?
Yeah, so I actually did go in and lower the data rates. Normally in Ekahau, we do recommend, or like kind of a starting point, I believe, is at 12 megabits per second for both 2.4 and 5. But that's obviously not the reality of what most manufacturers, when you get the stuff out of the box, it's always going to have the lowest data rates configured possible. So what does that, provide us? So before I change those, let's take a look at airtime utilization. And actually, let's even look at 2.4, since that's going to really have a big impact on the 2.4 side. So yeah, 2.4 you can see is obviously a big train wreck right now. Big mess here. If we hover over like this spot here, I'll just pick a random spot, and we can see how high our utilization is. And even at the bottom, you can see things like the data percent airtime, as well as management and control. And we can see, by adjusting the data rate, we should be able to influence some of that. So to the question of, what are the kind of impacts of that? By adjusting the data rates, we can, so I'll go to the network configuration here. By turning up the data rates, one thing that we're going to do is obviously increase the speed that the management traffic is being sent out at. So the management traffic, those beacons, everything that the network needs to provide the client devices to operate, is going to be sent at the lowest supported minimum data rate. So if we turn that up to, let's say, 12 megabits per second, we should see a significant change there. So I'll just change the 2.4 side now. I think I had my mouse over in this area. So you can see we've already started to clean that up a little bit just by raising that data rate, cutting off some of those lower rates. And what that does for me is increases, the data or the management traffic is now a lower percentage, right? Because we're getting on and off the air much faster when we're sending out our beacons, probes, those kind of things. We can get on and off the medium faster, free up some of that air time.
And I think this is a good example of a non-drastic change to the network, right? I see a lot of people in the chat just screaming like, move the APs. And yeah, you're totally right. And I think Jerry's going to get there. But this is something that you can strictly do in configuration. There's no recabling. There's no moving around ladders. Like it's something you can just change in config.
Yeah, absolutely.
Yeah. So
Jerry, one thing that I just wanted to point out here. When you're hovering over, it's popping up the box and showing 70% airtime utilization. So that's actually driven in Ekahau by the clients that you define and what applications you define. So in Ekahau, if you define a voice or video application, it will change the utilization from 70% to 60% and 50%.
Yeah. So what Clayton's talking about is, under here, you can see the limit on the far right there. It says 70% is the limit. And you can see we're actually just over that airtime limit right now. So we're actually getting pretty close with just some of the configuration changes. Still not obviously super optimal because we're still at 70%, utilization, but at least we're almost below that kind of limit threshold to be considered, where it's going to support at least something like data in this environment. So to Clayton's point, if we were to add into this area, you can see I have some client devices that I pre-set up in here, some smartphones, some laptops. If we want to add, let's say like a VoIP device in here, so we'll put in a VoIP phone, we'll even just put in 5 of them. It doesn't really matter how many. That's going to change the limits now for our airtime utilization to be what's considered acceptable, because we have now voice clients in that environment. So we've got like this area here. I believe that should change. No, it's still showing 70%, although that's on 2.4. Is it showing those guys probably on 5 gigahertz, I bet? No, it's still showing 70% there.
You got to go define a VoIP application.
So you're saying under, oh yeah, okay, because it put it as background sync. I gotcha.
Yeah,
So let's put actually the traffic being VoIP traffic, not just the device. Gotcha. So yeah, now we should have VoIP clients. There we go. Yep, and you can see it says voice in parentheses there. So since we're saying we're going to have voice traffic on the project here, we now need to raise our limit, our airtime utilization threshold to being below 50% to be considered passing. All right, so let's do a couple more things here and see if we can clean this up a little bit more. So on the network configuration side, this was at 5 SSIDs per radio. That's another way we can easily reduce the amount of management traffic. Not going to be earth-shattering most of the time, especially if you're just going from, I had this at 5 and I dropped it down to 3, but it certainly is going to free up some airtime on the management side. The less beacons that access points have to be sending out. So each SSID that it's configured per radio, that has to be sending those out at 102 milliseconds. For each SSID that you have configured. So right here we have 3 of those are being sent out every 102 milliseconds. So that does equate to some airtime. So the fewer SSIDs that we can deploy, the better. Especially if you're going from something like 10 down to 3, you can see a huge impact. And then the data rates are obviously going to apply to that as well by being able to increase the data rates. That's going to help. Now, one thing I would mention on the data rate side is you don't want to just blindly adjust data rates. So what's one of the first things that we need to do to figure out what data rates we can support? We can't just go in there and say, well, I'll just crank it up to 54 megabits per second, because as Joel talked about, as clients move away from the access points, they need to have the ability to rate shift, right? They need to be able to dynamically shift their rates down. And then there's the whole roaming process that takes place. The client might turn around a corner, they might put the phone in their pocket, something like that. We don't want just every time they have some change in their orientation or the device that they're going to drop off the network because we can't support those lower data rates. There's constantly those reasons why the client needs to rate shift. So to be able to figure out what rates we can support or what the lower rates we can disable, doing a site survey is a good way to do that, because now we can figure out what is the SNR of our network, and that's really what derives data rates. So if we know what our SNR is, and we know that we have a minimum SNR, sorry, I can't talk today. Here we can see we have 1.6% of our areas on this predictive model that have 25 to 30 dB. So we can be pretty safe to know that as long as we have data rates that can support, I would say even in this case, support at least 30 dB, we should be pretty safe to be able to turn off some of those lower data rates.
Hey, Jerry, what's the noise floor set at?
So if we go into the options here, we can see we've got these are actually new options that we just added in Ekahau Pro 10. So if you're running Ekahau Pro 10, you can statically set the noise floor now on per band, 2.4 and 5 gigahertz. So we can adjust that and see what that does to our SNR as well. So that's a nice way if you go on site with a Sidekick, you can measure the noise floor and then input that into your predictive model here. Or if you have those noise measurements from, maybe your access points provide those, or some other means of getting that number. All right, so that's the SNR piece. So let's go back to our network issues here and kind of see what shape of the network is. Now we're looking at 5 gigahertz. Things look pretty good on there. Really, the only thing that we're showing up now is just some number of APs issues in some of the corner spots here. And we could easily clean those up by pushing these APs into the corners. What that indicates is we only have one AP that's covering those areas. Now that's all 5 gigahertz. So we're looking pretty good on 5. However, from an SNR standpoint, we probably could improve SNR by moving these APs, pushing these APs closer to the clients. You can see a lot of these are classrooms around the perimeter of the building. So by having the APs in the hallway, it means that we're going to have lower an hour inside those rooms, and that's going to require our clients to talk a lot slower. Also, if we need to support 2.4 gigahertz, I just flipped over to 2.4, you can see things are still a huge train wreck on 2.4. So what can we do if we need to support 2.4 in this environment? Let's start with that, point of moving the APs, right? So we're just going to keep everything the same for now. And I'm just going to start moving some of these APs to what I would consider would be more optimal kind of locations. And then we can rerun a channel plan and see if we can clean up some of this. So we don't need to necessarily, I think in this case, move all of the APs out of the corridors, out of the hallways, but I would definitely want to move a very good majority of them.
Hey, Jerry. Why don't you click on the manual refresh button since you know you're going to be moving a bunch of APs.
Mm-hmm.
So every time he moves an access point, you'll notice that Ekahau is visualizing. If you hit that manual refresh button that Jerry just hit, it's now turned yellow. So you can go and make a bunch of changes at once and then go and turn the visualization back on. And it will then calculate everything as opposed to doing it every single time you move an access point.
Especially if you're Jerry and you're using like a 2005, like, I don't know, PowerPC MacBook or something like that.
Yeah.
Exactly. All right. So yeah, we can do it as now we turn the auto refresh back on and we can see things are still a pretty hot mess here on the 2.4 side. I'm going to just rerun the channel planner though, see if we can clean any of that up with a new channel plan now that we moved some of the APs. And really, it wasn't able to make any significant positive improvement. If anything, it maybe even made things a bit worse, meaning that there's just too many APs audible everywhere. So what else could we do on the 2.4 side?
Start turning off radios, Jerry.
Anything else before we start shutting down radios?
No,
Sridhar says power is high.
Yeah.
Pascal says turn off radios.
Yep.
Jim says turn radios off. Nick says power too high. Yeah, I think the message is coming through.
So I did a quick select here, selected all my 2.4 radios, and I'm going to say edit those selected simulated radios, and we're going to drop those down. I don't know. What do you guys, any suggestions on a DBM to try across the board on our 2.4 radios?
Raphael says 6. Celeste says 9.
I like 6. We'll start with 6. That's the nice thing is we can easily dial things up or down. And look at that. Yeah, huge impact now that we've got the APs out of the hallways and we've got that transmit power adjusted. We've now cleaned up a lot of that. And yeah, to Clayton's point, I think the next step would be to start selectively turning off some of these 2.4 radios. I would say probably even starting maybe with some of these in the corridors, since we're going to have good 5 gig coverage out there. So I can right click on these radios. Another option that I've seen some people do is where you actually start with having all the 2.4 radios turned off and then just selectively enable some of the 2.4 radios until you have minimal coverage of 2.4. So I'm just going to go around here and we'll just disable a handful of these 2.4 radios, especially ones that are more in open areas like the corridors. And now that we've got a bunch of those 2.4 radios turned off, I'm going to rerun our channel planner and see if it can try and make something out of that. And look at that. So we're actually starting to look pretty good. You can see we did create a few dead spots here. That's what the red is indicating. We've got weak coverage, but keep in mind that's just on the 2.4 side. So if I look at both radios, now combined together, we've now eliminated almost everything. We're down to less than 1% of issues on this network when we combine and look at things both together with 2.4 and 5. And if we look at just 5, it doesn't change at all. So we've got a really solid 5 gigahertz network. If we look at just 2.4, you can see we've pretty much limited all the co-channel interference on 2.4. We could probably fine-tune things a little bit better to clean this up a little bit more by improving our signal strength while, kind of it's a balancing act at this point, right? So as we improve our signal strength, we'll probably...
Iterative.
Yeah. Channel interference will increase with that. But yeah, we balance it out, make sure we don't have any significant dead spots on 2.4 while keeping the channel interference pretty low. Probably tweak the the transmit powers a little bit. We might be able to bump up that transmit power a little bit more as well.
I wonder if you bumped it up to 8 across the board, if that would, you probably aren't going to get rid of those coverage cells, but I'll bet that you could, or get rid of those dead spots, but I'll bet that you could minimize them significantly.
Try it out.
See what it does.
Bump that up to 8. There we go. So yeah, you saw the channel interference slightly grow, and the signal strength definitely shrunk quite a bit. So actually, I think that is a pretty good balancing piece, right? So now we're up to almost 80% of this floor plan having no issues on it on the 2.4 side, and on the 5 gigahertz side, yeah, it's looking really solid, less than 1%. And really, that's just a number of access points, which means in those particular areas, we only have one AP that's going to be servicing clients. So that could be a potential roaming problem issue, or just from a redundancy standpoint, or from a capacity standpoint, we may need to add, another AP or two to alleviate that. So yeah, you can see like in this section of the building, there's only one AP covering this area. So I might want to either move an AP or add an additional AP to help with that.
I think there's a lot of conversation in chat around, why leave 2.4 on at all. And it kind of comes down to the requirements. Like I would go and identify which areas it's absolutely critical that I have 2.4 on. For instance, my smart TV, it's not very smart because it only has a 2.4 radio in it, right? So I can't turn 2.4 off as much as I want to. Every other client in my house can connect to 5, except that one critical device. Clayton gets angry if he doesn't get Netflix.
Yep, I have a first gen Chromecast. That same thing. I have to leave 2.4 on, and so I do. It just depends on the requirements of your network. What are your requirements? What do you need to support? If you can turn off all the 2.4 gigahertz radios, awesome. That's super cool. I am so happy for you, but that's just not the reality for many, many people out there.
Mm-hmm.
Yeah.
So that's everything I've got on the demo side. Happy to go over anything else. I see we're already getting pretty close to the top of the hour here. So if there's any, I say we spend the rest of the time in questions, eh?
Yeah, let's do that.
Okay.
Cool. So I'm just going to start from the top and just kind of read through them here. So this first one is about RRM, and this is certainly not my area of expertise at all. And so hopefully I can lean on Jerry, Clayton. Maybe Jim can help me out a little bit with this one too. Maybe Jim, you've got some experience with RRM. The anonymous question is, or the question from an anonymous attendee is: most vendors have preset values for RRM, which range from 5 dB SNR improvement to 15 dB to RRM kick in. What is your recommendation to keep those thresholds low or high? Man, I don't know much about RRM here, so I don't know. Jerry, do you have any thoughts on this one?
Yeah, I mean, I think this is one of those things that can be a bit, I don't know, maybe not so much opinionated, but yeah. So I think there's different approaches to this of defining those kind of what I hear referred to as kind of the bumpers, I believe is what he's kind of getting at. You set kind of an upper and lower limit of RRM. So yeah, if somebody's got a good tip on there of kind of best practices around that. But yes, a lot of the same stuff that we talked about in the example that I showed of figuring out things like what is your SNR in your environment and what you can, what you're predictively modeling from a transmit power standpoint, right, to achieve those values. And then you set those kind of upper and lower limits. Actually, I think I just saw something from Jake Snyder recently on how he does that. And it was really kind of an interesting way of kind of using the predictive tool to adjust, I think it was attenuation actually in the walls, and then figure out what that dB value is until you raise the attenuation of like the objects in the environment to figure out, what that upper and lower limit is. So you raise the attenuation or lower the attenuation of the walls and see how that impacts the signal. And that's how you can define, what that upper and lower limit was. I'm probably not explaining that as well as, as Jake does, but I don't know if you want to reach out to him on Twitter. I know he's got some really good ways of doing that.
Jim says rule 1 with automatic radio stuff, never use defaults. That's probably good advice. Dan says he uses 7 and 30. It probably depends pretty significantly on the environment, though, is probably what I would say. So
yep. Funny, isn't there a wireless professional that's kind of his quote? It depends.
It depends. Yeah, I think somebody said that once. I can't imagine who. I don't think people like him very much. So I don't think he's very popular. So I'm kidding. Another question from Bruce here. What's a common threshold for interventional CCI, co-channel interference? What number of APs heard at what RSSI? Bruce, if you look in Ekahau, our default for this is like in the voice plus data profile, which I feel like is just kind of a good starting point. I like what that one says in there. That says no more than 2 access points above negative 85 dBm. You look at the Cisco design guideline. I think the Aruba high density or very high density guideline says this too is no more than 1 AP above negative 86. Those are what I would consider good starting points. Everybody will probably have slightly different opinions on that one, and that is okay. Clayton, Jared, you guys have any thoughts on that?
Yeah,
You can say no if you want.
no, that's pretty good. 1 to 2. If you go do RTLS, I think it's like 4 or 5 for RTLS. So again, it goes back to what are the requirements of the network that you're designing, right? And one other thing to keep in mind is that it's not just access points that cause co-channel interference. Clients can do it on the edge of a cell.
Yes, absolutely. Yeah, and that even like the way that I tend to explain co-channel interference, I always kind of focus on the APs. Clients do just as much, if not more, talking than APs, and so it just depends on which direction the traffic is going. They absolutely do cause co-channel interference. Let's see. Okay, question from Chad. Chad, I think this is a very good question. This may be beyond the scope of this talk, but how does multi-user MIMO impact the one device talking at a time? I think Jim gave a pretty good answer to this in here. Multi-user MIMO works in the spatial stream domain. I don't think it directly applies to the time domain that we're talking about with co-channel interference. Jim, I'm just going to read your answer here. Why don't we have Jim on these? What are we doing? We should just have him answering questions here.
He should be providing the color commentary. I mean, come on, guys.
Yeah, he should. Yeah, totally. Jim says, I'm just going to read it. 802.11ac multi-user MIMO uses different spatial streams to send to different clients at the same time. Downlink only, so AP to client only. And he says it never really worked in the real world environment. 802.11ax, on the other hand, here we're getting our 802.11ax checkbox checked here for this webinar because you have to talk about AX, right? 802.11ax will use resource units or RUs to slice the spectrum up into smaller channels to allow multi-user MIMO, both on the uplink and the downlink. I think it was Chuck I think Chuck gave a talk a couple of years ago on multi-user MIMO, and I think that he found that if they use like a bunch of 2x2 Chromebooks in the same environment, they had a 30% increase in throughput with multi-user MIMO, but it relied on a lot of factors had to line up perfectly. The stars had to align perfectly for that to happen. In the real world, with a mixture of different data being sent to different devices with different capabilities, it just doesn't work. Do you guys remember that being the same way, or am I misremembering that?
Yeah, no. And what I was going to say, I think from Jim's answer, which I think was fantastic, I think one of the key points there is it never really worked in the real world environment. Yeah, that was one thing I was going to actually pull the audience on and see if anybody's actually successfully using multi-user MIMO in their environment, because there's so many factors in play to actually get the benefits out of multi-user MIMO. One of those being, things like an iPhone, even the latest iPhone model does not support multi-user MIMO to my understanding. So we have the latest and greatest devices, in certain categories still do not support this technology. And for it to be really beneficial, all devices on the BSS have to support that technology to really get any real world benefits out of it.
Yeah, absolutely. Jim, thank you for your contributions on that one. Much appreciated. Let's see. Just looking through lots of other questions. I don't know, Clayton, Jared, you guys see any here in the list that you want to tackle?
What's an easy one?
Well, that's another contribution from Jim here is about extended Uni2E channels. So has anyone enabled extended Uni2E channels and had success? Again, it goes back to what are the requirements and can the client support it? So the biggest thing to keep in mind about Uni2E channels is that a lot of clients, even current ones, like our favorite Nintendo Switches, can't see some of the channels. And if you can't see a channel, then that access point doesn't exist to the client, right?
Yep. So I do see a question here. Actually, the top question here on my list, at least, is around RX SOP. I am not an RxSOP expert by any means. I've never even really played around with the feature myself. I have been involved in some pretty interesting conversations about that. And I just saw a really interesting conversation about that on the Wi-Fi Pros Slack. So I would actually encourage you guys, if you're not on the Wi-Fi Pros Slack, I think it is still kind of an invite only thing. But if you want to shoot me an email at jerry@ekahau.com, I can hit up one of the admins, get you guys in there. But the conversation around the RxSOP, as I recall it, was there was actually some really interesting takeaways on the low RSSI. So the conversation was more around using RxSOP, which is the best explanation I heard of RxSOP is basically putting earmuffs on your AP, and basically your APs are not listening at a certain threshold. So they basically kind of, even though they could technically hear and decode that information, if the RSSI is a certain value, it's basically just going to kind of pretend it didn't hear that, right? It doesn't respond to things, which can be really bad from a client experience when you think about it, because if a client is connected and you have RxSOP, it's a very fine-tuning kind of knob of you can mess things up very quickly, because if a client, again, kind of turns around a corner, puts a phone in their pocket, whatever, all of a sudden the AP just says, oh, you're talking too quiet, I'm not going to respond to you anymore. It's not going to do that proper kind of rate shifting, that kind of thing. So there's a better option, which is that low RSSI was kind of the takeaway from the conversation that I saw, at least something to maybe look into, where it actually won't respond to probes from clients that are below a certain RSSI value. The difference there is that you're preventing weak RSSI clients from joining the network in the first place versus allowing them to join and then not responding to them. So yeah, it's a very interesting topic for sure, and I'm sure we can go down a whole rabbit trail thing, and I'm sure that's another one of those highly opinionated topics. And like I said, I am not an expert in RxSOP at all, but that's been my takeaway from it.
Really good question here. I think we should probably answer is from Valerie. From the Ekahau software perspective, using Sidekick, how can you identify co-channel interference? Can you demo an example of behavior using this tool? Valerie, that is a great question. So all of the visualizations, this is one of my favorite things about Ekahau, all of the visualizations that Jerry was showing you earlier on the planning side, the predictive modeling side, totally work on the measured data survey side of things. You probably remember we kind of went over this slide a little bit on how to visualize co-channel interference in Ekahau. If you look at the channel interference visualization, Jerry spent some time on this one. Notice that there's actually surveys in here. This screenshot is from a survey. And so instead of this being, a simulation of what things are going to look like, this is based on real world data. So for example, in the gray areas, that's where we are failing to meet our requirements. In the green areas and the yellow areas, that's where we're passing our requirements. So channel interference is the one that I always go to look and see what co-channel interference looks like. Jerry also spent a lot of time in the network issues visualization. You remember seeing a lot of pink or magenta in there. That it was just a simplification of the channel interference. Whatever we show, like wherever Jerry was showing that there was pink there, that is where we were failing the channel interference requirement. So it all works on the survey side, pretty much identical to the planning side.
And I did see something in chat about 3D planning. So yeah, I did actually kind of take that into consideration for this demo. I thought about creating more of a 3D model, but just figured it might go a little bit too complex to try and explain some of this stuff. We can absolutely do that in Ekahau. Obviously adds a lot of complexity to it. And it is certainly a very valid point is, we're looking at things kind of the easy route of, more in just a 2D single floor plan. But yeah, what if this was a 5-story building that we were working with and we have signal propagation from floors above and below? Now it becomes that much more complicated to factor in that extra axis of, where these signals are coming from to try and eliminate this co-channel interference. So yeah, you saw how kind of difficult that was, or easy it was, I guess. In the single floor, you can think, how much more variables we have to consider when it's a multi-floor plan. But the good thing is Ekahau does support that multi-floor planning, and even the channel planner and everything will take that into consideration as it's doing the auto channel plan for you to figure out what the right channel width and channel plan is going to be.
So we probably only have time for a couple more questions. So I'm just going to kind of keep going keep going from top to bottom here to kind of answer these. Any plans on being able to simulate SSIDs within the airtime utilization window? You probably remember now, maybe you asked this before the demo, but actually, Jerry actually turned off some SSIDs. Originally, he had 5 SSIDs when he did that demo, and he actually curbed it, brought it back down to 3 SSIDs, and that is factored into the utilization or the airtime usage calculations. And so when you pull away additional SSIDs, Ekahau calculates that. That only works on the planning side. It does not work on the survey side. So in the real world, what you'd have to do is turn off those SSIDs, do a quick resurvey, and look at the results and see how things have changed. But you would have to do that in a live environment where people are actually using it. So that might not be a bad idea to go ahead and model that really quick and see what that would look like in a model. There's also some good resources out there. The Revolution Wi-Fi capacity planner could probably help you with that. There's also a nice spreadsheet on Revolution Wi-Fi's website that talks about how much airtime is used by different SSIDs. And so you could probably look at those resources and put something together to figure that out. Probably the last one that we can answer here live on the webinar. Question is it true that too many access points is it true that too many access points is only going to affect budget, or when co-channel interference occurs, if we have access points with a unique channel, would it not only add to capacity? Any thoughts on that one, Jerry? I definitely have thoughts on it. I can go either way.
Yeah, no, I think it's a good question. I think it's too many access points can certainly be a bad thing. You can always obviously turn off access points. You can always turn off radios. So yeah, then it just comes down to more of a cost standpoint. Obviously, there's the cost for the access point, but cost for licensing, switches, cabling, all that kind of stuff. So yeah, getting the right number of access points is very ideal from a cost standpoint. But from an RF perspective, we can certainly work with if we have too many access points. It may not be ideal or be optimal, but we can optimize the environment, and it may just entail turning off certain access points or at least certain radios to make it all work.
Yeah, absolutely. Cool. Well, I think we're about 10 minutes over time here, so we should probably go ahead and wrap things up. Now, there were a lot of really great questions that unfortunately we did not have time to get to. Apologies for that. Fortunately, that's pretty typical on these webinars that we just can't quite make it through everything in time, but we really appreciate you guys being engaged. We really appreciate the discussion in the chat and things like that. Jerry, do you have something to say?
I was going to say, this is technically, I think, a part 1 series as well, isn't it? Don't we have a second part to this coming up?
Yeah, but I forget the details on that.
I don't remember exactly what it was off the top of my head, but I remember when we planned this out, we figured we weren't going to be able to cover everything in here. So there's going to be a second interference one. I think it might be more on non-Wi-Fi interference, actually, and the impacts of non-Wi-Fi interference. So
I think you're right.
Kind of continue this conversation somewhat in a little different direction. So stay tuned for that. It'll probably be, I think we've got one other webinar between this one and that one, but yeah, keep an eye out for that in the coming weeks.
And so email addresses are all listed here. I'm going to try to spell Clayton's last name here. There's Clayton's email address as well.
Hey, you got it right. Look at that.
I got it right. Well, I guess I have a cheat sheet sitting right here. Your name is literally on my second display. I could have looked at that. But anyway, if you have questions that we didn't get to, you want to drop us a line, feel free to do so. You can reach me at just joel@ekahau.com or just jerry@ekahau.com. Clayton, I don't know if Clayton@ekahau.com works for you. We'll have to test that. But either way, shoot us an email and get in touch with us. We'd be more than happy to chat about this stuff more. Thanks for being here. Thanks for being a part of this webinar. If you want to check it out, if you want to rewatch this for some reason, then keep an eye on our webinars page on our website. Our awesome marketing team usually gets these posted in less than 24 hours. So keep an eye out for the recording there. It'll be posted on YouTube and linked from our website. Okay, that's about it for this one. So we'll see all of you in a future Ekahau webinar. Have a great rest of your week.
Thanks, everybody.
Bye now.